everyone, this is Srikanth, working as assistant professor in electrical department. Now we are moving to very important topic, that is mesh analysis. So in this video we can get the what are the steps and how we'll solve the mesh currents in each loop. So I'll give the small information on this video. So why I want to find out the mesh analysis? Why I require the mesh analysis techniques? That means where we have the number of loops, for each loop I need to find out the currents. For each loop, for each branch, for each element I need to find out the currents. For that purpose I require the mesh analysis techniques, mesh current analysis techniques. If we want to find out the mesh analysis, we require one more technique, that is Kirchhoff's voltage law. So what is the voltage law? In a closed loop, right? In a closed loop, sum of voltages drops equal to 0. In closed loop means there we have some current flow. So any closed loop we have different currents. We have different loops means we have different currents. So each loop we have different current means for each branch also different currents. For mesh analysis we have some steps to find out the mesh currents or unknown branch currents or unknown loop currents. Okay, now just observe the steps. The first one is identify the number of loops. Identify the number of loops. In my circuit I have n number of loops. If I have, I can find out the loop currents. Okay, so I need to identify the number of loops, how many number of loops we have. And second one is I have like 2 number of loops, so I have the 2 currents. So I just give the direction for those 2 currents. And third step is apply the KVL rule. Apply the KVL rule for each loop. Then find out the loop currents. Then find out the unknown value current. Okay, only 5 steps. First identify the loops, then identify the direction of your loops, then apply the KVL rule and write the equations and solve those equations and get the unknown values and unknown values of loop currents. And just last one is find out the where you require the current, where you require the branch current or element current, you can find out that value. Okay, these are the steps to find out the mesh currents. Okay, now for this I have a small circuit here, 2 voltage source I have and 2 loops I have. Okay, now what are the steps? So first step is I need to identify the number of loops. So how many loops we have in this circuit? We have 2 loops. So 1 and 2 loops I have. And then what is the second step? Give the current direction. Here I want to follow the source current direction. So my source current direction is upwards. Same thing here, upwards. So give the current direction for each loop. So this is my current direction, upwards. Same thing here also. From this side, this is upwards. Now write the equation. What is the third step? Apply the KVL rule. So write the equation for each loop. So what is the voltage drop in loop 1 as well as voltage drop at loop 2. At loop 1, what is the voltage drops? Suppose at source voltage I have voltage drop is so negative to positive. I have minus V1. At source we have the minus 1 volts. Coming to R1, what is the voltage drop? So for voltage VR1 equal to I into R1. Am I right? So what is the I here? So general V equal to I into R. I want R1 value, VR1 value. So that is I into R. So what is the I here? In this branch at R resistor, how many currents we have? At R resistor we have only one current, that is I1 current. So VR1 equal to I1 into R1. Clear? At voltage drop across R1 equal to I1 into R1. Coming to voltage drop across R3. So what is the current at R3 resistor? So how many currents we have? So just observe. At R3 resistor we have I1 current as well as I2 current. So here in this branch we have I1 current as well as I2 current. So both are same direction, not reverse direction. Both are same direction. And the voltage drop across R3 equal to, what is the V formula? V equal to I into R. R is your R3. Then what about I? I is we have 2 currents. 2 are same direction. 2 are same direction means I1 plus I2. So I want here voltage drop means I into R. So R is your R3. But your I is, we have two currents. Two currents is same direction. That means I1 plus I2. Same direction currents. If suppose both are reverse direction, so this is downwards and suppose these are upwards, then I1 minus I3. Clear? Now your voltage drop across R3 equal to I1 plus I2 into R3. Okay. Coming to R2 resistor. What is the voltage drop? How many currents we have there? We have only one current. That is I2 current. That means I2 into your R2 value. Coming to voltage source. V2 voltage source. The current direction upward. So you will get like minus 2 volts. Okay. So these are the voltage drop across each element. Then write the equation for each loop. At loop 1, write the equation using KVL, and loop 2 also write the equation using Kirchhoff's voltage law. Then voltage drop across in this loops equal to 0. From loop 1, your equations are minus V1, this is a voltage drop, and plus I1 into R1 is a voltage drop, and this is one voltage drop. I have 3 voltage drops. Now check it now. Minus V1 is there, and voltage drop across R1 and voltage drop across R3 equal to 0. Then from coming to like loop 2, same as your loop 2 also same equation. Voltage drop across source and voltage drop across R2 and voltage drop across R3. Here, so if suppose both currents are reverse, then loop 1 equation is I1 minus I2 into R3. From loop 2 equation is I2 minus I1 into R3. That is the reverse. Okay, when the both currents are reverse, then the equation is depending upon the loop current. So here loop current is I1. So I need to write the I1 minus I2. Here loop current is I2. So when you are writing the loop 2 equation, you need to write I2 minus I1 into your R3 equal to 0. So two equation, two unknown values. Just solve those equations, you will get the answer I1 and I2. And then find out nothing but your mesh currents and find out the unknown values. If you want like a R1 current value means that is I1 current. If you want like R2 current value means that is I2 current. If you want like R3 current is I1 plus I2 currents. Okay. This is your mesh analysis steps. We will solve small problem on this. Okay. So same circuit, but I given like some values for voltage as well as resistors. Then what is your first step? Identify the loops. So I need to identify the loops. 2 loops I have. Then current direction. Same current direction using source I1 as well as I2. Then what is the voltage drops? Apply the KVL rule. Means I need to find out the voltage drop across each element. So voltage drop across source is minus 5. Voltage drop across I2 ohms is I1 into 2. And voltage across 3 ohms is voltage drop across 3 ohms is I1 plus I2 into 3. Same as your 4 ohms resistor is I2 into 4, and voltage drop across 10 ohms is minus 10. Now write the equation. Loop 1 equation is minus 5 I1 into 2, I1 plus I2 into 3 equal to 0. And same thing, loop 2 equation minus 10 I2 into 4 plus I1 plus I2 into 3 equal to 0. Just solve those equation. We'll get like equation number 1, equation number 2. So unknown values. How many numbers unknown values we have? 2 unknown values, I1, I2, and 2 equation. You can directly solve it using calculus. We'll get like I1 equal to 0.192 and I2 equal to 1.346. I have mesh currents now. So I know the I1 value is 0.192 and I2 value is 1.346 amps. Now I want like 3 ohms current. Okay. So examiner wants like 3 ohms current. What is the 3 ohms current in this circuit? Then what is the value? So here the two currents are same direction. Same direction means your value is 0.192 plus 1.346. This is your value at R3 ohms resistor. If suppose, so both currents are reversed, then your I3 value is minus I1 minus I2. Okay, depending upon the current direction, your value will be changed. Okay, that is minus value or plus value, not your main value. So main value is same, but your direction is different. When your current direction is changed, then your sign will be changed, minus sign or plus sign. That's it. Value is same. Value is same, but if direction is reverse means you will get the minus value. Direction is same means we will get the plus value. That's it. Okay. This is about mesh analysis. These are the steps for mesh analysis. Using this step, you can find out the mesh currents. Thank you. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.